So, section 6.3 is the very first introduction to logarithmic functions. We're going to start off in hopefully a little bit easier of a thing to understand before we get into the more complicated stuff. Basically, you guys have always been able to figure out, so I'm going to put this part down here, what you've been able to figure out. You have been able to figure out this equation very easily, right? Because you know what an exponent is and you know what an exponent does. Our question, or our thing that we are going to introduce now, is going to be, how do we solve for an exponent? How do we solve something for an exponent? So this is something you're comfortable with. You're comfortable with exponents. That's great. We are solving the type of question where it is along the lines of 2 to the x power equals 7. This is not something that you know how to do. There's basically only one method that you guys would use to solve this. And that method would be guess and check. You would say something like 2 to the second power is 4, 2 to the third power is 8. So x is going to be between 2 and 3, right? 2 to the second is 4, 2 to the third is 8. So somewhere in between 2 and 3 is going to be where that x value is. So then what we're going to do is we're just going to start plugging in numbers and hope that it clicks. Now that's a really good thing if they're asking you something as simple as 2 to the what power equals 7, right? Very simple thing when you're asking this. When you introduce it into an equation, it gets to be much more challenging. Okay, so just keep in mind when you're dealing with SAT related things, they're not going to give you something as simple as 2 to the x equals 7. Okay, so we're going to get into how to solve this in a little bit, but this is the idea of logs. This is why logs exist. So this is why logs exist. Okay, this is why we have to use it. So it's a pretty important concept, pretty important idea, because you need to know what you're dealing with. Now, there is a big idea that we need to get very comfortable with, because I'm going to ask you to do this over and over and over and over and over again. There is something called log form and exponential form. Log form and exponential form. Log form is when you have some log. Now this is going to be kind of an introduction into what you're looking at with logs. With some base, and this base is below. It's like a subscript, okay? So that base is a subscript. And then the way that you say this is of something else. So this would be called log base b of y, okay? Log base b of y equals x. Okay, that would be what an initial setup for an equation would look like, and then you use that initial setup to, I guess, fine tune it however you want, or solve it if you know how to solve it. Right now, the easiest thing for us to do is going to be to convert this thing into exponential form. This number is called the base. B is called the base. Log base b is called a base, and with exponents, remember we have bases, right? We have a number raised to a power. That number that we're raising the power to is called the base. So the base doesn't change, but we can switch the x and the y, which should make you think of the word inverse. Because remember when we deal with inverses, inverses are always switching x's and y's. That's because logs and exponential equations are inverses of each other. Logs undo exponents, exponents undo logs. Okay? So it's logs and exponents are the same thing to each other as multiplication is to division, as addition is to subtraction. Logs and exponents are inverses of each other. Okay? Now this is something that right now we are going to have to kind of just make sure that we practice and understand. We're going to need to make sure that we understand those simple concepts. Because once we start with the building blocks and we can start to build from that, I think you guys are going to start to see how the relationship between logs and exponents actually work and how they exist. Okay, so let's start out just by showing a couple different things. So let's say that I've got an equation or an expression that looks like this, where it is log base 2 of 16 equals 4. Let's say it looks like this. That is gibberish to me, right? I don't know what a log is, so that means absolutely nothing to me at all. It might make a little bit more sense if you put it into exponential form, because that's what you comprehend. That's what you get. I'm going to be honest with you. I've been doing this for 6 years, and I still don't like looking at log form because it doesn't really make sense to me right off the top of my head instantly every time. Once we get into the swing of things, it starts to get a little bit easier. But like right now, I haven't looked at logs in a year, so I don't like that form. But we just got done doing a whole bunch of exponents, so that makes a lot more sense to me. So I'm going to change this to exponential form. Look at it like this and say, oh, okay, I get it. I get what it's trying to say to me. So if I switch it back and forth from exponential form, it's a lot easier. But when you look at this, basically what this is saying on the left side is, it is saying I have to multiply 2 how many times by itself to get 16. So this is saying I have to multiply 2 how many times by itself to get 16. Rewriting things in a different form is a lot easier to look at, because this is saying I have to multiply 2 by itself 4 times to get 16. It's saying the exact same thing, just in a different way, because I've switched those x's and y's, because those numbers are those functions are inverses of each other. Okay, does that kind of make sense so far? Logs and exponents are inverses of each other. It's kind of almost like a reciprocal. I don't want to call it a reciprocal because it's not, but I want you to think about it as it's kind of like the same thing as multiplying by 5 and dividing by 1/5. Right? Multiplying by 5, or if you want to say dividing by 5 and multiplying by 1/5, that's the same kind of thing, same kind of concept. They're just inverses of each other and they look different. Same thing's happening here. It's saying the same thing, it's just a different way to look at it. Okay? So hopefully that kind of makes sense. Hopefully you're kind of understanding what to look at for those. Okay? Now I want to start out just with the notation that you find on your calculator, because it's going to be really important. Okay? You're going to find on your calculator the log button. That is called the common log. Oops. So the log button on your calculator is called the common log. This is the one that you'll find on your calculator that says log x. The one you find on your calculator says log x. Now, there is no base there. So there is no number in that expression or that equation, whatever you want to call it. There's no number there. It is understood that this has a base of 10. So this thing right here is the exact same thing as saying log base 10 of x. You know how in square roots we don't put the 2 next to the radical? And with an x, we don't put a 1 in front of an x to say that there is one x? The same thing is happening here. It's just understood that there is a log base 10 because that's the most common one that's used. Okay? So that's the most common log that we use the entire time, log base 10. You're just going to use log base 10 for pretty much everything that you do. You might have to change bases around and stuff, but log base 10 is always going to be the button that you use on your calculator. Not always. It's going to be the most common one that you use on your calculator. Okay? There's also another one, and this one relates a lot to what we talked about yesterday. There's one called the natural log. And the natural log is given to you by ln. Does anyone have a guess what that base might be? Remember we introduced the natural base yesterday? E. So the natural log is going to have the base of e. So it really means log base e. These two things are the exact same. Log base e and ln are the exact same thing. They mean the exact same thing. If you see log base e on a test, it means ln. If you see log or ln on a test, it means log base e. No matter what you see, backwards or forwards, log base e and ln mean the exact same thing. They are identical. So they mean the same exact thing. There is a question that is going to show up on your chapter. I don't remember if it's a test or a quiz, but there is something that's going to show up on your chapter 6 test or chapter 6 quiz that says something along the lines of log base e of x minus 7 equals ln of x plus 2. I'm going to give you something like that. And that is to not really trick you, but to identify if you understand that log base e and ln are the same thing. Because if they're the same thing, you can just drop them and forget about them forever. But log base e and ln are the same exact thing, and I'm telling you right now, I will give you a question on your test that says log base e equals ln, and it will trick people, and people will get it wrong. So right now, if there's one thing to take away, log base e and ln mean the same exact thing. It's just different notations for the same exact phrase. Okay? A couple other things to kind of think about is if I am asking you to find log base b of 1, and asking you what that number equals. I want you to change, and I want you to try to tell me what this number right here is equal to, and I want you to try to figure out how you could understand that. How can you get to the point where you can understand that? Because right now this makes no sense, right? This is a different language to me on the board right now. Log base b of 1, no clue what it means. So put it into a term that you're comfortable with. Put it into a term that you know how to use, and tell me what number is going to be on the right side of that equation. Any ideas? Not quite. Yep. Not B. Oh, wait, is it B? Hang on, I don't remember. So right now what I would do is, we'll call this X, right? I don't think it's B. So we'll call that X because we're looking for it. So I have B to the X power equals 1. How do I get something to be 1 when I have an exponent? Yeah, what? 0. So that means anytime you're taking the log of a number, it is going to be, I'm sorry, anytime you're taking log base anything, doesn't matter what the base is, of the number 1, the answer is going to be 0. So that's like the nicest thing that can happen ever. If you have like log of 1, log base 5,000 of 1, that answer is 0 and you're done. Okay? So that's a nice one. This one's a little bit different, but not really. This one, log base b, oops, log base b of b. So again, use the same concepts, the same idea to try to tell me what this is equal to. So try to tell me what log base b of b is. Go ahead, Tanner. This one's 1. So this one we're going to rewrite as our exponent. So I have b to the x power equals b. Now obviously if I put x to anything else other than 1, it would not be b on the right side, right? In order for b to equal b, it has to be b to the first power. So this answer is 1. This is your introduction to the properties of logs. Right? There are a bunch of properties of logs, a bunch of them. We're actually going to end up going through probably 6 or 7 more, I think. So I think we're going to do 6 or 7 more properties of logs. This is 2 of them. Okay? So as we work our way through, hopefully you're able to kind of understand and start to see why logs will have some sort of relationship, why we'll be able to use logs, why we'll be able to use exponents, and when we'll be able to use each one. Okay? So this is a really, really important concept that you understand the idea to be able to switch between exponential form and log form. So I'm going to give you a couple of these and try to make you solve them, see if you can come up with what's going on, and see if you can figure out the log, see if you can figure out what's going on. All right? Now that being said, there are ways that you can solve these with calculators. So I'm not going to force you to use, like if you know how to use your calculator, that's fine. If you don't know how to use your calculator, I'm going to try to get you to do this without a calculator. Okay, so if you don't know how to use a calculator on this, then it's not going to help you anyway. But I want you to try to solve things that look like this. So if I ask you to solve log base 4 of 64, if I ask you to solve log base 5, this one's tough, of 0.2, or if I say log base 1/5 of 125. So I want you to try these 3 and see how you can get it without a calculator. Again, if you know how to use your calculator, that's fine. If you don't, it's better. It's actually better that you don't know how to use a calculator because you have to try to solve this by hand, which means that you have to understand the relationship between logs and exponents. So give it a shot, and we'll talk. All right, so the biggest idea that you should do, or that you should come up with, is switching these back to exponential form, right? So that means I don't know what any of these equals. So the first thing I would do is I would start by putting an x there, so I know that I can very easily flip things back and forth and know what I'm looking at. But this is saying right here that 4 to the x power is equal to 64. This one is saying 5 to the x power equals 0.2. And this one is saying 1/5 to the x power equals 125. So there are some tricky ones here. But this one should be the easiest one. What does x equal here? We got 3, right? 4 to the third power is 64, so x equals 3, easy enough, right? The one on the right is a little bit more challenging because it's a decimal, and I'm not really comfortable with decimals because it just doesn't really make sense. What if I rewrote this as 5 to the x power equals 1/5? How do I make a number go from the numerator to the denominator? Go ahead, Tanner. I use a negative power, right? So if I say x is equal to -1, that means 5 to the -1 power is the same thing as 1/5. So that gives me my value. Okay, it's just a negative because it's using it's making it go from numerator to denominator. Okay, but spoiler alert, same exact thing happens in the third one. Right? I have a fraction and I want it to turn into a whole number. So if I have a fraction and I want it to turn into a whole number, I have to use a negative exponent as well. So basically, I'm saying, what number does 5 have to be multiplied by to, or I'm sorry, how many times does 5 have to be raised to a power in order for it to be 125? 5 to what power? The third power equals 125, right? But if I just say that x equals 3, that's going to give me 1 over 5 to the third, which is 1 over 125, and that's no good. I want it to be whole number 125. So I'm going to raise it to the negative third, so it's going to be x equals negative third. All right? No homework tonight. Flush your ice cubes down the toilet. Sleep with a spoon under your pillow. Sleep with a spoon under your pillow. Enjoy the rest of your day, folks.